Today, after watching this video, you're going to be able to answer two questions. What is phase and what is polarity? Hello everybody, and welcome to WavSpot. For those of you who don't know me, my name is Austin Knaus, and I've been working with audio for over 20 years. The first job I ever had was as a radio station engineer for WVLP 98.3 FM, which is a small college town radio station in Indiana. Over the following years, I made my way into electronic music production and in live performance as a touring DJ, opening for labels such as Mousetrap, Anjuna Beats, and Intricacy Records, and playing music festivals such as Dance Festopia, Backwoods Music Festival, Spring Up Celebration, and Impact Music Fest. After live events took a hit in 2020, I ended up selling my entire music studio and starting a more stable career path as a technology specialist for Shure microphones. On top of that, I represented a multitude of other brands such as Klipsch speakers, LEA amplifiers, Listen Technology, Rain, and Denon Professional. Now, here in 2024, I fly all over the USA commissioning C-suite and executive level conference rooms for some of the top ranked Fortune 500 companies, and I didn't even graduate high school. I'm taking everything that I've learned along the way and boiling it down to the basic fundamentals in hopes to provide you with a fast track to understanding the world of sound. So, let's dive in. Okay, so if you remember the last video, I'll tag it up here, we talked about what a frequency is. A frequency is a measurement of cycles per second, or hertz. And we learned that they were comprised of one positive amplitude and one negative amplitude. In order to understand phase, we need to understand polarity. So what is polarity? You already understand that a frequency has a positive amplitude and a negative amplitude. And to make this easy, polarity is equal to amplitude. So if the amplitude is a positive amplitude, then so is the polarity. You have a positive polarity. If the amplitude is a negative amplitude, you also have a negative polarity. So if we have a positive pressure, we have a positive polarity. If we have a negative pressure, we have a negative polarity. So now that we understand what polarity is, we can start getting into the question of what exactly is phase. While polarity indicates whether the amplitude is positive or negative, phase is measured in degrees and indicates the point of time that the cycle is in. Let's open this up a little bit. What would happen if we cut the wave in half? We have a positive section, and then we have a negative section, and then we overlap them, right? So what we would do is we would cut it in half, and then we would overlap it. We would get a circle. A circle is 360 degrees around, right? So if we drew half a circle, we would have 180 degrees. If we drew a full circle, we would have 360 degrees. Well, with our wave, at the peak of the positive amplitude, we would be at 90 degrees because we moved all the way up. And at the bottom of the positive polarity, we would be at 180 degrees because we had traveled from the top back to the bottom, back to neutral. So we went to a certain distance and then turned around and came back. Now, if we move to the peak of the negative amplitude or the peak of the negative polarity, that would be 270 degrees because at that point, we have traveled 90 degrees away from 180. Moving back up to neutral or back up to the middle, we're now at 360 degrees and we're starting our cycle over. While it's good to understand this, I want to explain how we can actually see it and what makes it useful and why it's important and where to apply it. So we need two waves, two frequencies, in order to be able to view phase. So what's positive 1 plus negative 1? 0. What's positive 1 plus positive 1? 2. What's negative 1 plus positive 1? 0. This is really important to understand, and this is why phase is important. There's two scenarios that we can have when dealing with phase. It's either in phase or it's out of phase. Gray area, it's somewhere between in and out of phase. So if we have two waves the polarity of wave 1 is positive, and the polarity of wave 2 is also positive at the same time. That's considered in phase. If the polarity of wave 1 is positive and the polarity of wave 2 is negative, happening at the same time, that's considered out of phase. A simple equation is +1 plus -1 is 0. This is phase cancellation in its basic form. If wave 1 is in its positive polarity and wave 2 is also in its positive polarity, the amplitudes of the two waves are then summed. This is called superposition. It's also called constructive interference. For example, if we have an amplitude of 10 on wave 1 and on wave 2 we have an amplitude of +5, we add them together and we get an entire amplitude of +15. Now what happens if we have a wave, wave 2, that's out of phase with wave 1? If we have, let's say, +10 amplitude on wave 1 and on wave 2 we have a -5. If we add those together, it's actually a +5 because the amplitudes cancel each other out, because one is slightly more negative than the other, because one is actually negative and the other one is positive, so you subtract from the positive or add to the negative, whichever one is greater. If we had a -10 amplitude and a +5, that would be a -5 amplitude after said and done. I like using the +1 plus -1 math equation because it's really simple, it's basic. +1 plus -1 equals 0. It's an easy concept to grasp. If the frequencies are identical and their polarities line up and they're perfectly in phase, they'll actually amplify each other. It's called superposition or constructive interference. Now, if the polarities are opposite of each other at the exact same time and they're the exact same frequency, you won't hear a thing because it cancels itself out. So it's one thing to talk about it and explain it. It's another thing to actually witness it happen. Okay, so I have two identical frequencies. We're working with 371 hertz in particular. No real particular reason, just it wasn't really high pitch and it didn't hurt my ears. So here's what it sounds like. And we can see there is a simple wave. Now I'm going to add a second wave. And it might be a little bit louder because now there's two. So we have here our 371 hertz wave. When I unmute this other 371 hertz wave, watch what happens to our original. It doubled in size, and that's because of superposition, in other words, constructive interference. That is the summing of amplitudes when two identical waves are in phase. What happens when we flip it 180 degrees? So I opened this tool called Serum, which is actually generating our frequency for us. And we can see here, there's this knob called phase. And if I move that knob, we can see that it actually is calculated in degrees right below the knob there. And we can go all the way to 360 degrees. So what happens if we slowly move that wave that was once doubling the amplitude of the other wave? What happens if we move the phase to 180 degrees? Well, check this out. Our wave disappeared. It's as simple as that. +1 plus -1 equals 0. We can see we have a full amount of volume, but nothing's coming out of the speakers. We can't hear anything. That's because of phase cancellation. Let's put it back to 0. Let's put them back in phase. To me, that's crazy. So if we have one frequency, 371 hertz in particular, and we add another 371 hertz wave, amplitude is summed together. And then if we flip that second wave 180 degrees in polarity, we completely lose sound. Goes away just like that. So what happens if we have one frequency that's constant and we have another one that slowly moves up in pitch, but it's also 180 degrees in phase, and they happen to cross at the same time? What happens then? Check this out. We just witnessed constructive and destructive interference, just like that. Let's do another one. This time, we'll do a high pitch to low pitch, but we'll have it go really slow. This time we can see all three waves, both the wave that's constant, the wave that's changing, and what happens all together. Okay, so what is polarity? Polarity defines whether the amplitude is positive or negative. It's pretty simple. If the amplitude is positive, so is the polarity. If the polarity is negative, so is the amplitude. Phase is both a measurement of where the wave is within its cycle using 0 to 360 degrees. It's also a method of comparing two waves and where they are within their respective cycles in relation to each other and to what degree they are aligned. If the first wave is in its positive polarity and the second wave is in its negative polarity, that's considered 180 degrees out of phase. In other words, it's undergoing phase cancellation, which results in no sound at all. If you found this information useful, hit that subscribe button, share it with one of your friends. You might help them out. If you have any other topics that you guys are interested in, give me a comment down below and I'm more than happy to start making videos for you guys on your specific needs.